Good evening. My name is Saloni Patel, and along with my partners, Melanie Pham and Aastha Patel, we are here today to discuss one of the most significant yet often overlooked consequences of climate change, called ocean acidification. In this video, we'll be exploring how changing chemistry in our oceans is impacting ecosystems, economies, and human health.
To understand the problem, we first need to understand the chemistry behind it. Ocean acidification is the gradual decrease in the pH of our oceans over time. As we burn fossil fuels, more carbon dioxide is released into the atmosphere, which is then absorbed by the seawater. When carbon dioxide reacts with water, it forms carbonic acid. This chemical reaction does two things. It increases the acidity of the water, and it reduces the concentration of carbonate ions. This is a huge problem because many organisms, like corals and shellfish, depend on these carbonate ions to build their shells and exoskeletons. So, as the water becomes more acidic, it becomes dangerous for these organisms to survive, which affects the entire marine ecosystem.
So what is actually causing all this? The primary reason is carbon dioxide emissions from human activity. This includes the burning of fossil fuels for electricity and transportation, as well as emissions from factories. Additionally, deforestation plays a role. With fewer trees, less carbon dioxide is absorbed by the atmosphere, which leaves more of it to settle into our oceans. While ocean pH can naturally change, the rate at which it's changing today is unheard of in recent geological history. This shift directly correlates with the start of the Industrial Revolution.
These industrial activities don't just change the chemistry, they change the physical state of our planet. As carbon dioxide increases, so does the global temperature. This heat leads to the melting of polar ice caps and glaciers. This contributes to habitat loss among many species that live in these cold regions. As shown in the graph, there has been a steady, steep rise in sea levels from the 1900s to 2018, a total increase of over 212 millimeters. This rise, combined with acidification, creates a stressful environment for coastal ecosystems, as they are targeted by both rising, warmer waters and increasingly acidic conditions.
The impacts aren't just environmental, they are also socioeconomic. In the US alone, the shellfish industry, which includes oysters, clams, and scallops, has an annual value of $400 million. But by the year 2100, consumer losses are projected to hit nearly $500 million annually, mainly because these organisms won't be able to survive in more acidic waters. Beyond just the US, over 500 million people worldwide rely on coral reefs for food, income, and tourism. As these reefs start to degrade, we lose what are called ecosystem services. This means coastal communities lose their natural protection against storm surges, leading to increased flooding and higher costs for rebuilding and infrastructure. Furthermore, tourism revenue from snorkeling and scuba diving, which are major drivers for many island nations, is also at severe risk.
When we look at the major consequences, it's a ripple effect. Physically, we face malnutrition and potential poisoning as seafood quality alters. As the water chemistry changes, it can lead to malnutrition in populations that rely on fish as their primary protein, or even poisoning if the environment triggers more toxic algal blooms. Respiratory issues can even arise from the aerosolized toxins produced by these algal blooms that thrive in these conditions. The degradation of our coastal environments impacts human well-being and leads to a loss of discovery as biodiversity declines. This diagram helps visualize that interconnectedness. On the top half, you see the physical health loop, how changed air quality and altered seafood leads to respiratory issues and malnutrition. On the bottom half, you see the mental health loop, which shows how the loss of recreational spaces and biodiversity leads to distress caused by environmental changes. This graphic highlights a grim trend. Biodiversity is decreasing in major areas around the world, with significant drops in Latin America and the Caribbean. We're losing species faster than we can study them.
Looking closer, the organisms that are the most impacted are calcifying organisms. These include corals, mollusks, and crustaceans. They produce calcium carbonate to build their homes. In low pH, low calcium seawater, these organisms cannot maintain their shells. They become brittle, grow slower, and in extreme cases, their shells even dissolve. When the reef dies, the entire community of marine life living within it disappears.
Our research also looked at specific simulations for the Arctic and Antarctic regions. These polar waters are particularly impacted because colder water absorbs CO2 more easily. Simulations for the 2090s show that the top 200 meters of our ocean will see drastic shifts in pH levels. This is showing us that the most remote parts of our planet are often the first to feel the heaviest impacts.
To conclude, ocean acidification is a mainly human-driven crisis. It damages the environment, threatens the survival of calcifying organisms, and has long-term consequences for human food security and the global economy. However, by understanding these impacts, we can better advocate for the reduction of carbon emissions and the protection of our marine resources. Thank you for your time.
And this is our bibliography.